Section 13.3 talks about area, the Pythagorean theorem, and volume. And so in this section, we're going to talk about the Pythagorean theorem and its converse, the measures of sides in special right triangles, and the distance formula, as well as the equation of a circle. So we have the parts of a right triangle here. The legs are what we refer to as the sides that are adjacent or right next to the 90-degree angle, okay? So the ones that are here and the ones that are there. And then we have the hypotenuse. A hypotenuse is always going to be opposite of the 90-degree angle, okay? And so here is the Pythagorean theorem. You might remember this from high school because they talked to us about it a whole lot, right? So it says, given a right triangle with legs A, B, and hypotenuse C, it says C squared equals A squared plus B squared, right? So a lot of times they wrote it like this, A squared plus B squared equals C squared, but it's the same thing. Okay, and it says if BC is 3 centimeters, and if AC is 4 centimeters, what's the length of AB? And it has the answer right here, but let's see if we can't figure it out. So BC, this side right here is 3, and AC, this side over here is 4. We're going to look for that side right there. Okay, so all I'm going to do here, guys, is just a straight substitution. I want you to notice that this is my little letter A, that's my little letter B, and we don't know what C is. So under A squared, I'm going to put 3 squared, plus B is 4 squared, is equal to C squared. So 3 squared is 9, right, because it's 3 times 3. 4 squared is 16, because it's 4 times 4. We're going to add 9 and 16 together. That's going to give me 25 equals C squared. So to find C, we're going to take the square root of 25. Remember what the square root means. The square root means what number multiplied by itself gives me 25, and that would be 5. And that's why they have the answer right there is 5 centimeters, okay? So let's see if we can figure out how to do some of these problems here. And it says, use the Pythagorean theorem to find x and y in each of the following. Okay, so first thing I'm going to do in all these problems, guys, I'm going to write down my formula, my Pythagorean theorem. Okay, remember, the important part is that the side over here is C. Once we know that, which one we call A, which one we call B, not a whole lot important, okay? So in this case, I'm just going to call this one A, call this one B. We know that's our C. So A is going to be 12 squared plus x squared is equal to 13 squared. So 12 times 12 is 144 plus x squared. 13 times 13 is 169. Now we're going to subtract 144 on both sides. I'm going to move this over a little bit so I have a little bit more room. X squared equals, let's see, 9 minus 4 is 5. 6 minus 4 is 2. Those ones cancel. So x squared equals 25. So again, we're going to take the square root on both sides. And the square root of 25 earlier we said was 5. So there's our missing piece right there, okay? Alrighty. Let's try the next one here. First thing I'm going to do, write down my formula, okay? Now, again, the reason why I'm writing it down, the more that I write it down, the easier it's going to be for me to remember and how to apply the formula, okay? So let's take a look here. Remember, the important part is which one we call our C. This one here is going to be our C. So let's call this one A and this one B. So we're going to say 30 squared plus 16 squared is equal to x squared. So I'm going to grab my calculator. Let me turn it on, clear it out. Okay, so I need to figure out what's 30 squared. 30 squared should be like 900, big number. Plus, let's do the same thing, 16 squared is 256, is equal to x squared. So now we're going to add those two numbers together. Let's see, 900 plus 256, and I'm coming up with 1156 is equal to x squared. So now we're going to take the square root on both sides. Okay. And let me grab my calculator again. So I want to take the square root, so I'm going to go second. There's my square root right above the x squared of 1156. 56. Close off my parentheses, hit enter, and we're coming up with 34. Okay. Alrighty. So let's take a look at the next one we got here. Okay, so again, remember, this is my 90-degree angle. That's my side C. Okay, so I'm going to write down my formula. A squared plus B squared equals C squared. Okay, so let's call this one here A. So we're going to say x squared plus 18 squared is equal to 30 squared. Okay. Oh, come on, pen. Let's see, what's 18 squared? So 18 squared is 324. We did 30 squared a little while ago. That was 900. So now I need to subtract 324, or 324, I'm sorry. Okay, let me take my calculator. What is 900 minus 324? And I'm coming up with 576. Now I'm going to take the square root on both sides. Okay, so let's see. Square root of, we can even do it like this. My answer, right above the little negative sign at the bottom, there's a little ANS, that's my answer. And coming up with 24. Okay. All right. So we have an equilateral triangle, okay? And it's saying that we're trying to find that value of x right there. Okay. So let's see. If this whole piece here is s, right? Then this whole piece is also going to be s. And this piece right here, just that part right there, guys, would be s over 2. Okay. So if I were to think about my right triangle here, let's see. Okay, so now let's take a look here. Let me get my pen. Okay, so this here is going to be like my C. We'll call this one our A, and this piece here will be our B. So again, the formula is a squared plus b squared equals c squared. Okay, so a is going to be x squared. B is going to be s over 2 squared. And c is going to be s squared. Okay, we're just going to go in pieces, don't worry. So s squared is s squared, obviously. 2 squared is 4 equals s squared. Okay. So now I'm going to move this s squared over 4 on both sides. Okay. And I'm going to think of this piece here, guys, as a fraction. Okay. I'm going to think about it right now over 1. So I'm going to have, let's see, I'm going to have x squared is equal to, now in order for me to get these two guys together, we need a common denominator. And that denominator is going to be 4. So I'm going to put a 4 here, and I got to put a 4 on the top. Minus, remember, this is really like a 1s squared over 4. Okay. So 4 minus 1 is 3 s squared over 4. So now when I want to solve for x, I'm going to take my square root. Okay. So let's see what we know. I know the square root of s squared is just going to be s. And I know that the square root of 4 is going to be 2. What I don't know is, what's the square root of 3? Since it's not a nice, pretty number that I can actually simplify, I just leave it like that. I leave the square root on the 3 because there's no number, no pretty number, I should say. You know what I mean by pretty number, right? Like pretty number like 2 times 2 is going to give me 4, something like that. There's no pretty number that when I multiply by itself is going to give me 3. So we just leave the square root on there, okay? All right. So now let's take a look at this next one here in our list. So we're trying to find the two missing pieces, x and y, and we're going to find them separately. Okay, so we have a cube here with sides 3. So remember, This is 3, this is 3, this is 3, this is 3, right? So if you look, we have this right triangle right here, right? There's my 90-degree angle. So this is going to be my C. So I'm going to say, okay, a squared plus b squared equals c squared. All right, and we're going to go through in pieces. These are my a's, and that's my b. So I'm going to say 3 squared plus another 3 squared equals x squared. So 3 squared is 9, and another 9 equals x squared. So 9 and 9 is 18 equals x squared. Now, one thing I want to talk about in talking about squares, remember we said we're going to take the square root on both sides. And we might say, do it like this. We might say, you know what, I don't know a nice pretty number that multiplies to 18. And that's true. I don't know a nice pretty number that multiplies to 18. So I'm going to kind of show you a little something here on the side in dealing with square roots, right? So if I asked you, what's the square root of 25? We would say it's 5. And I said, what's the square root of 49? We'd say it's 7. And if I said, what's the square root of, say, 64? We would say it's 8. And if I said, why? Because look, how many 5s do we need to get 25? We need 2 of them. How many 7s do we need to get 49? We need 2 of them. How many 8s do we need to get 64? We need 2 of them. So the square root means I'm grouping in terms of pairs. So whatever I have a pair of, that's my answer. I have a pair of 7s, so the answer is 7. I have a pair of 8s, the answer is 8, right? So when I come back to this particular problem and I say, well, you know what? Can I break down 18? Can we break it down into 2 and 9? And 9, isn't 9 3 and 3? So we have a pair of 3s. You know what number we didn't have a pair of? That 2. It's got to stay inside the square root. And there's my answer. Okay? So now we know that, let me clean up some of this mess. We know that now that x value is right here. This is the same thing as 3 times the square root of 2. Now, we also know that this side going down from here to here is 3. What we're trying to figure out now is, what is that diagonal distance over there? So again, if you notice, we're going to have a right angle right here. So these are going to be my legs, and this one here will be my hypotenuse. That'll be my C. Okay. So let's see. I'm going to write down my formula again. I'm going to write down a squared plus b squared equals c squared. And so how about if we call this one here a, and we call this one here b? So we're going to say 3 squared plus 3 times the square root of 2 squared is equal to our hypotenuse. In this case, we're using the letter y squared. Okay. So we're going to go slow here. 3 squared means 3 times 3, that's 9. Okay. I'm going to actually write this out so it looks like this. Remember what it means to square something. It means to write it down 2 times. Okay. When I'm multiplying this one here, y'all, these numbers here are going to multiply, and then these numbers here are going to multiply. Okay. I'm trying to go really, really slow here. So now look, 9 times, what do we know the square root of 4 is? So the square root of 4 is 2. Okay. So 9 plus 9 times 2 is 18. Is equal to y squared. So 9 and 18, when I add them together, gives me a 27 equals a y squared. We're going to take the square root on both sides. So that's y. Now I want to think about my number 27. I know there's not a nice pretty number, but I bet you we can break 27 down. We know that 27 is 3 times 9. And we know that 9 is 3 times 3. And remember, when we're taking the square root, we're looking for pairs. So you can decide, I'm going to pair these up, or you can decide you're going to pair these up if you wanted to, right? You're going to take, but it's only one pair, okay? So, let me write this back. Okay, so what number do we have a pair of? 3. What number did we not have a pair of? That 3. It's got to stay on the inside. And there's my other piece. Okay. Alrighty. So doing the same thing here. This problem is similar to the one we just did right now. So let's see if we can find this x part right here first. Okay, let's see if we can find that part. We already know this side here is 12. Do we know that side? Yeah, it's 20, right? Because it's 20 down here, so it's 20 up here, and it's 20 back there. Okay, so look, this is going to be my hypotenuse. We'll call this one our A and this one our B. So I'm going to write it down here for y'all. A squared plus B squared equals C squared. And we know that our A is 12. So this is going to be 12 squared plus 20 squared equals C squared. So 12 squared is 144. 20 squared is 400 equals C squared. So if we add these together, we should get, let me turn this back on, 144 plus 400. And I'm coming up with 544 is equal to C squared. And now we need to take the square root of it. So first off, when I have a big number like this, my first guess is going to see, can I actually take the square root of 544? I don't know if I can or not. We're going to find out right now. And we can't, because we come up with this kind of messed up number like this, right? It's not a nice, pretty number. That's okay. Now we're going to worry about breaking it down. Okay, when the number is massive like this, I don't think about, can I try 20 or whatever? I just start saying, look, it's an even number. Can't we divide it by 2? Yes, we can. So what's 544 divided by 2? It's 272. This is also even, means I can divide it by 2. So what's 272 divided by 2? 136, okay? And I'm going to keep playing this game until I can't play it anymore. So I'm going to divide that one by 2. So 2 and 68. Okay, we can divide 68 by 2. And this is 2 and 34. And I can divide this by 2, and this is 2 and 17. Now remember, I'm looking at the ends of my, like this is kind of like a tree diagram, they call it. I'm looking at the ends. So I'm going to start grouping. Look, there's one pair of 2's. There is 2 pair of 2's. And these numbers here are not paired up. So those numbers are going to go back inside my square root. So let me show you how I'm going to write this out. We have a pair of 2's here. I'm going to write it down. We have another pair of 2's right here. So I'm going to write that down. These two guys are going to be multiplied and go back on the inside. And 17 times 2 is 34. And again, the reason they're going back in is they're not paired up. Okay, so I have them grouped here, but they're not in a pair. Okay, and that's equal to C. And so then we're going to say 2 times 2 is 4. Square roots of 34 is equal to C. So this is the side that we were looking for. So let me come back over here. Okay, and I'm going to clean up some of this mess here. And we're going to say that this side now, x, is 4 square root of 34. Okay, so now let's think about the next part we're trying to find. We know this distance. We just found it, 4 square roots of 34. We know this distance, it's 7. We're trying to find that value of y. Here's my 90-degree angle. This is going to be my C. Okay, so we'll call this one our A, and we'll call this one our B. And I'm going to do this over here on the side. So the first thing I'm going to do is I'm going to write down A squared plus B squared equals C squared. You got it. And then I'm going to come back over here and I say, what was my A again? C. My A was 7, and my B was 4 square roots of 34. So this is 7 squared. This is 4 square roots of 34. Squared equals C squared. Okay. And I'm going to go slow. So 7 squared. 7 times 7 is 49. Remember, I'm going to write this one out twice because that's what it means to square something. Okay. So now I'm going to go 49 plus, remember how we're doing this. These numbers are going to multiply. So 4 times 4 is 16. Okay. The square root of 34 times another square root of 34 is just the number 34. Okay. And let me show you why. If I were to go, remember we said we're going to multiply those numbers together, right? So if I were to go 34 times 34, we'd end up with something like 1156, but that's still on the inside of the square root. And so then if I said, okay, well, what's the square root of 1156? Oops, 1156. I'd end up with 34. Why? Because I had two 34s, right? Okay, so now we're going to multiply these numbers together. So let me get my calculator again. We're going to say, what is 16 times 34? 544. Okay, so we have 49 plus 544 equals c squared. We're going to add those together now. So 544 plus 49 is 593. Okay, so c squared is equal to 593. And remember, we're going to take the square root on both sides. So 593 is a huge number, right? But I know it's not even, so I can't divide it by 2. So the first thing I might try is, okay, well, if I can't go by 2, can I go by 3? No. Okay, 3 doesn't work. Okay, so the next number I would try would be, I'm not going to mess with 4, because if 2 doesn't work, 4 won't work. I would try 5, but I know 5's not going to work either. So then I might try 7. And no, 7 doesn't work either. Okay, so then I might try, say, 11. Oops, not 10, but 11. And that doesn't work either. Okay, so I'm just trying to see if I can break this down. Maybe I'll try it by 13. And that doesn't work either. Okay, so I might try, say, 17. And that doesn't work either. Okay, I'm using my prime numbers here, y'all. Okay, so I might try 19. Nope, that's not going to work either. Okay, and this one might just be one that doesn't break down. So I might try, let me see, next prime number in my list would be 23. And that's not going to work either. Okay, so then I might try, let me see, the next number in my list for primes would be 29. And nope, that's not going to work either. And so then I might try 31. And nope, that's not going to work either. So guys, our answer here, we're going to, at some point, we're going to have to say we got to stop. So my answer here is going to be the square root of 593. And that is this distance right here, this y value. Okay, so we'll go here and we'll say this is the square root of 593. Okay. All right. So let's take a look at the next problem here. It says, determine whether the given numbers represent the lengths of the sides of a right triangle. Okay, so C is going to be the hypotenuse. That's always the longest side. Okay, so we're going to say this is C. We call that one A and B. And we're just going to double check to see, is this going to work out? I don't know if it will or not, but we'll try. 9 squared plus 7 squared is supposed to be equal to 11 squared. So this is 63, and this is 49. And if I add 63 and 49 together, I come up with 112. But if I take 11 and I square it, I come up with 121, and those aren't the same. So the answer here would be no. Now, if these two numbers ended up equaling each other, then my answer would have been yes. Okay. So let me take a look at the next problem here. It says, starting from point A, a point sails due south for 4 miles. Okay, so I'm going to just call this my point A right here. And we're going to go south. We're going to say that's a distance of 4 miles. And then we're going to head east. Okay, so this is going to go for 6 miles. Okay, we're going to end up right over here. And then we're going to go south again for another, see if I can draw this good. We're going to go for another 6 miles. The question says, how far is the boat from point A? Okay, so now this is where we ended up with, and we're trying to see, can we find this distance? So I bet you we can. Couldn't we extend this and do this number here and make this look like a real pretty right triangle? And if we knew that this distance here was 4, then we would know that this distance here would also be 6. So that would tell me that my total distance from here to here would be 10. And we already knew that this piece here was 6. And we are looking for, let's see, I'm sorry, that's not 6. What part do we know? This piece here is 6, I'm sorry. Okay, and we're trying to find that distance right there. Okay, so remember, this is going to be my A, this will be my C, or my B, I'm sorry, and that side there will be our C, right? We're looking for that distance right there. So first thing I'm going to do, I'm going to write down my formula over here. I'm going to say A squared plus B squared equals C squared, right? So A is going to be 10, so we had 10 squared plus B is 6, 6 squared equals C squared, okay? So 10 squared is 100, 6 squared is 36 equals C squared. So this is 136 equals C squared. Remember what we're going to do? We're going to take our square roots, okay? So 136. And again, I'm always going to try to see if I can break these problems down. I know it's even. We can divide it by 2. What's 136 divided by 2? 68. I can divide it by 2 again. That's 34. I can divide it by 2 again. That's 17. We are looking for pairs. Boom. That's one pair of 2. These numbers are not paired up because they're different, so they're going to go back on the inside of the square root. So C is going to be 2 times the square root of, when I multiply them together, what do we get? 34. And this will be in miles. Okay. Now, I'm looking at the problem here, and I don't know if it's going to ask you to round. Okay. So I'm going to show you if it was going to ask me to round. What we would do is we would then use like these kind of squiggly equal signs. And the way we would do this, we would say, I want you to look at what I have right here. I have 2 times the square root of 34. So I would type that directly into my calculator. 2 times the square root of 34, close out the parentheses because mine opened them up, and I'd hit equal. And suppose it told me to round to 1 decimal place. If it asked me to round to 1 decimal place, if I have 11.66, I would actually have to write 11.7 miles, okay? So I'm just doing this here in case it asks you to do some kind of rounding, okay? You'll have to look at the directions, and if it asks you to round, then you'll want to go ahead and do that. If it doesn't ask you to round, then you'll be okay. All right. So the next part we have here, deal with special right triangles. So in special right triangles, when we have what's called a 45, 45, 90 triangle, okay, that's why it says right here, 45, 45, 90, whatever the measurement here is, S, these two will be the same, and the hypotenuse is going to be S times the square root of 2, okay? And then we have another one called the 30, 60, 90 triangle. So here's my 30. This here is going to be 60 degrees. And there's obviously our 90. Okay. So whatever this measurement is here, this one here is going to be twice that. And then this measurement here will be this number times the square root of 3. Okay. So let's take a look at these problems, and we're going to see if we can't figure it out, okay? So the first thing I'm going to do, I'm going to look at this triangle right here. And if I notice, the first thing I'm trying to find x. Since this is my right triangle right here, this is going to be my hypotenuse, okay? So we'll call this side A, we'll call this side B. So remember my formula, A squared plus B squared equals C squared, right? So we're going to say 6 times the square root of 3 squared plus 6 squared equals C squared, okay? And I'm going to try to do this slow again. So remember the first piece, I'm going to write it out like this. 6 times the square root of 3 times another 6 times the square root of 3. 6 squared is just 36 equals C squared. So we're going to multiply those together. That's going to give me 36. The square root of 3 times another square root of 3 would be the square root of 9, but we know the square root of 9 is just 3 plus 36 equals C squared. Okay, so now I'm going to take my calculator and move it over here so y'all can see what I'm doing. So I'm going to say, what's 36 times 3 plus another 36? Okay, and I'm coming up with 144 is equal to c squared. So now when we take the square root on both sides, we're going to get 12. Okay, so I'm going to come back over here, and that's telling me that this side right here, y'all, is going to be 12. Okay, now we still need to find this piece over here. Okay, okay, so because we know that side is 12, then that tells me something. That tells me that we're dealing with a 30, 60, 90 triangle. This is 30, this piece here is 60, and here's my 90. So now, well, if I know that in this triangle, this is 90, this is 60, this angle up here, guys, is going to be 30. So if this piece here is 6, I want you to come back over here and I want you to look at this picture here, okay? Whatever this side is here, this piece is going to be half of it because this is double that. Okay, so if this is 6, this piece down here is going to be 3. Let me use a different color. Let's go with red. That's going to be 3. And if this is 3, then this side here is going to be 3 times the square root of 3 because of that 30, 60, 90 triangle business. So if you notice right up here, let me erase this so y'all can see it a little bit better. But whatever number I have here, this is going to be half of it. That's why we said if this was 6, half of that is 3. And then whatever side is here, the way I'm going to find this distance is just by multiplying it by the square root of 3. And so since it was 3, we did 3 times the square root of 3. Okay. Now we have a second triangle, and it's this one over here. So I want you to notice this is 45 degrees. So that piece is going to be 45 degrees. And we're trying to see if we can find this entire distance here. So I want you to look at the 45, 45, 90 triangle. Okay. I'm going to clean up some of this mess so we can see it a little bit better. Okay. So when we know this side here, the hypotenuse, it's being multiplied by the square root of 2. It's whatever the legs are times the square root of 2. So when I come back to my problem here, here is my 45, 45, 90 triangle. And we said whatever this distance is right here, this one will be the same thing except multiplied by the square root of 2. So this distance here, just this little piece, is going to have to be 2. Well, if that one is 2, that means that this one is going to be 2. So my x is going to have to be 4. Okay. Well, if this piece here is 2, and this is another leg, y is also going to be 2. Okay. So I'm trying to break them down to make them look like those particular triangles that we have. Okay. So let's see if we can do this next one here. It says a company wants to lay a string of buoys across a lake. To find the length of the lake, they made the given measurements. What is the length of the lake? All right, I bet you we can do this. Here's my 90-degree right triangle, right? This is my, this is my A, this is my B, that's my C. Let's write down our formula. Guys, by the time we're done with this one section, you're going to know the Pythagorean Theorem, front ways and back ways and sideways and slant ways and all that kind of good stuff, right? So we don't know what this distance is. We're going to call it x. So x squared plus 24 squared equals 37 squared. Okay. So I'm going to grab my calculator. I need to figure out what's 24 when we square it. 24 squared is 576 equals, what about 37 when we square it? It's going to be 1369. Okay, so let me subtract 576 on both sides. Okay, we said we're going to minus 576, and I'm coming up with 793. Okay, and so now I'm going to see if I can simplify this thing here. So let me grab my calculator again. 793, can I divide it by 3? I don't know. I can't. Okay. Can I divide it by 7? I don't know. I can't. Okay. Can I divide it by 11? Nope. So again, I'm just trying to break down my number here. Can I divide it by 13? Yes, there we go. Okay, so we're getting somewhere because we're taking the square root. And we know this is 13 and this is 61. I don't know how much that's going to help me, but I know now I'm dealing with 61. 61 is actually a prime number. And so both of these numbers here are prime. There's no numbers that multiply to, I don't think I can break down 61. I know I can't divide it by 3, can't divide it by 7, can't divide it now. That's a prime number. Okay. So my answer is just going to be x is equal to the square root of 793 because I can't simplify it anymore. And again, if they do ask you to simplify it, you're just going to go second square root. Oops, sorry about that. We go second square root of 793. Oops, 793. And whatever they ask you to round it to is what we're going to round it to. So again, if I was asked to round to 1 decimal place, I would write 28.2. If I was asked to write to 2 decimal places, I'd write 28.16. It's just going to depend on what they ask you to round to. I'm just going to do 1 decimal place right now. But again, if there's specific instructions, make sure you do that. So I'm going to put 28.2. Right? Yeah, 28.2. Okay. Feet. Okay. So the next problem here says, find the perimeter of a triangle with vertices at 0, 0. So here's my point, 0, 0. -3, 1, 2, 3, and -4, 1, 2, 3, 4, right over here. And -7, 0. 1, 2, 3, 4, 5, 6, 7. So we're trying to find this perimeter here. Okay. And so we want to see if we can find some of these distances. Okay. Well, we know that the distance from here to here is going to be 7, right? That one we know. So the next thing I want to see is, could we find some of these other distances? So if I count 1, 2, 3, 4, okay, I know the distance from there to there is 4. 1, 2, 3, I know the distance from here is 3. I'd like to see if we can find, say, that distance right there. So again, here's my 90-degree angle. That would be my C. So let's call this one A and let's call this one B. So we're going to say 3 squared plus 4 squared equals C squared. Actually, I should have written out my formula first. Sorry about that. Okay. So 3 squared is 9. 4 squared is 16 equals C squared. So this is 25 equals C squared. So 5 is equal to C. So I know that this distance from here to here is 5. Now we want to see if we can do the same thing for the second part. Okay. So I want to know, I want to know, what about this? So I know that this is still going to be 4. And if this is 1, 2, 3, let me see, 1, 2, 3, this is also 4. Think about it this way. If these two sides are the same, this is one of those 45, 45, 90-degree triangles. This side here, guys, would be 4 times the square root of 2. And if I'm being asked to find the perimeter, all we're trying to do is, can we add up those sides there? So we're going to say 7 plus 5 plus 4 square root of 2. Those are the ones that I can actually combine. So I'm going to say 12 plus 4 square root of 2. That would be my answer. Okay, I couldn't really do much more with it than that, other than just that. And that would be the perimeter of my triangle. Okay, so we have something now called the distance formula. Okay, and here is our distance formula. Okay, and I want you to basically understand that this is like an adaptation of the Pythagorean theorem. If you're trying to find the distance between these 2 points, well, if you know this distance here and you know this distance here, then that would be the hypotenuse, right? And so we would say we're going to take this distance here, we're going to square it, we're going to take that distance there, we're going to square it, we're going to add them together, and we would have like a squared plus b squared equals c squared. So if I wanted to solve for c, I would just take the square root on both sides. And I'd have whatever that distance is, a squared plus b squared, right? And that's exactly what we have here. So I'm going to kind of walk you through this process so you can kind of see what I'm getting at, all right? So there's my formula. In my formula, we have numbers like x2 and x1 and y2 and y1. All that refers to is when I'm dealing with points, remember, my points are always in the form x and y. So x1 and y1 will be the x-coordinate and y-coordinate of the first point. So what I mean by that is this is going to be my x1, this will be my y1, and this will be my x2, and that'll be my y2. So for part A, if I'm going to find the distance, I'm going to copy down the formula that we have right here, x2 minus x1 squared, y2 minus y1 squared. Okay? And we're going to go in slow motion. Okay? So x2, what is my number x2? It's the number 0. You don't have to go but it helps. x1, what is my x1? It's 0 again. Okay. All right, y2 is the number 2. Notice I didn't go And y1 is the number 4 squared. Okay. So let's see. We're going to do order of operations. Parentheses first. 0 minus 0, 0 squared. 2 minus 4, negative 2. Notice I'm keeping it in parentheses, squared. Okay. So 0 squared is still 0. A negative 2 times a negative 2 is a positive 4. 0 plus 4 is 4, and the square root of 4 is 2. So for part A, there's my answer. Okay, we figured it out for part A. Now let's do the same thing for part B. This is my x1 and my y1. That's my x2 and that's my y2. Okay, so I'm actually going to do it right here because, believe it or not, I got enough room. Okay, x2 minus x1 squared, y2 minus y1 squared. Okay, so let's see, x2 is 12, minus x1 is 0 squared, y2 is 0, minus y1 is 9 squared. Okay, remember, like we said before, we're going to do the parentheses first. 12 minus 0 is 12. I'm keeping in parentheses, squared. 0 minus 9 is negative 9, keeping that in parentheses, squared. Okay, so 12 squared is 144. 9 squared, or negative 9 squared, a negative times a negative is a positive. Okay, and so now I'm just going to grab my calculator. Oops. That's not the one I want. This is the one I want. Let me get rid of this other one here, guys. Okay, let me turn this guy on. And we're going to have 144 plus 81. And that's giving me 225. Oops, let me see. Come on, pen. There we go. 225. And when I take the square root of that, that's just going to give me 15. Okay. All right. So we do have another one, and we're going to write that one down here. This is my x1 and y1. That's my x2 and y2. So let me do this over to the side where I need some space. C. Okay. The distance formula. First thing I'm doing, I'm just copying down the formula. x2 minus x1 squared. y2 minus y1 squared. Okay. So x2, let me clean up some of this mess so that everybody can see it. Notice there's negatives here, okay? So each of the coordinates have a negative. x2 was this one right here, negative 21. Okay, so we'll write it down. Negative 21 minus, because there's a minus there. This one right here, negative 18. Oops, negative 18. I forgot my negative. Come on, pen. There we go. Minus a negative 18. Okay, y2 is this number right here, negative 20. Minus y1, which is a negative 8. Okay. All right, so remember, minus and minus make it plus. So if I owed you $21 and I had 18, that's going to leave me with a negative 3 squared. Okay, minus and minus make it plus. Negative 20 plus 8. If I owed you $20 and I only paid you 8, I'm still going to owe you 12. That's why it's a negative. Okay. So negative 3 squared is a positive 9. 12 squared is a positive 144. Okay, so I'm going to grab my calculator again. 144 plus 9 is 153. And I'm going to take the square root of this, and you know what we can divide it by? We can divide it by 3. And that's 51, and I think I can take 51 and divide it by 3. Divide it by 3. Yes. 3 and 17. So notice, what do we have a pair of? We have a pair of 3s. What do we not have a pair of? 17s, and that one stays as it is. All right. So let's see. Okay, we're almost done here. I think this is the last part, y'all. And we have the equation of a circle with a center h and k and the radius r, and we have a formula here. Okay, so first thing is the center is the point h and k. I want you to look at the formula here. There's a minus in front of that h, and there's a minus in front of that k. Okay, so the directions here say find the equation of the circle with the given radius, with a given center and radius. Okay, so the first thing I'm going to do, I'm going to write down my formula. Okay, so I'm going to say x minus, look at what number h is. It's a negative 9, so you got to put a minus negative 9. Plus y minus, look what k is. K is a number 10, so I'm just going to write 10 squared, equals the radius, which in this case is 4 squared. So first thing is here, a minus and a minus make it plus. So this is going to be x plus 9 squared plus y minus 10 squared equals 4 squared is just 16. Okay. Now I'm going to do the same thing for the next one. Here we go. First thing I'll do is I'll write down my formula. X minus h squared, y minus k squared equals r squared. Here's my h and here's my k. So x minus, again, a negative 9 squared plus y minus k is 1 squared equals the square root of 5 squared. So like we did before, minus and minus make it plus. So, come on, pen. X plus 9 squared, y minus 1 squared. Remember what we said, the square and the square root are going to cancel each other, and that's just going to leave me with a 5. Okay? And so this here should be the last, there's still a little bit more. 2 more problems, guys. Give the center and radius of each of the following circles. Okay, so first thing I'm going to do, I'm going to write down my formula. X minus h squared, y minus k squared equals r squared. And we're going to do this in pieces, okay? So I'm going to take a look. I'm actually going to do part B first because I want you all to do a little stare and compare here with me. When I do part B, look at the formula. X minus 6 squared, y minus 3 squared equals 81. Remember, the center is the point h and k. So I told you this earlier. I said, look, the center is h and k, but notice there's a minus here and there's a minus here. So if I do that, my h is 6, my k is 3. The radius, this number here is the radius being squared. So I have to find the radius, to find the radius, I need to take the square root of the last number. And the square root of the last number of 81 would be 9. Okay. So now let's do part C. We'll come back and do part A in a little bit, but let's do part C. It says x plus 7 squared plus y minus 4 squared equals 15. So the center is the point H and K. So I have to change this sign here. So my H is a negative 7, but this sign stays the same because it's already a minus 4. So it just stays as a 4. And then my radius would be whatever the square root of 15 is. I can't simplify it, so I'm going to leave it like that. Okay. Now let's go back and do part A, and then we can do part D. So part A gave me the equation x squared plus y squared equals 36. So I can think about it as x minus 0 squared and y minus 0 squared equals 36. So my h and my k in this case are going to be 0, 0. And the radius will be the square root of 36, which is just 6. Okay. And then there is a part D, as in dog. So x squared plus y plus 2 squared equals 16. So let me write it over here. X squared plus y plus 2 squared equals 16. Again, I'm going to think about it like this. X minus 0 squared. Y plus 2 squared equals 16. So again, my h and k in this case are going to be 0 and a negative 2, and the radius is the square root of 16, which is 4. Okay. All right, so still got a few more to go. Sorry, I thought we were done. All right, guys, I know this is kind of a long section. Let's see. One leg of a right triangle is 3 centimeters and the hypotenuse is 5. Joni found the length of the other side by evaluating the square root of 3 squared plus 5 squared. What error did she make? So let's take a look at the problem. Look what it's telling me. So we have a leg of a right triangle. And we know one of those sides is 3. And it says the hypotenuse is 5. So if we're trying to find, say, this distance here, right, wouldn't we say x squared plus 3 squared equals 5 squared? And this is how we would set it up. And notice what she's doing here. So if we were going to solve this problem here, if we wanted to solve this particular problem, what should we have done first? We should have said, okay, this is 9, this is 25, and we should have subtracted 9, right? So which one here has subtraction? That one there. That would be our answer. Okay. So I'll tell you what, guys, we're going to stop it there. You won't have this problem in your homework, and you won't have, that problem in your homework either. And that was 13.3.